Should we do another example? I think we should. So here is your second example of how to complete the square to write a, what we call a general form parabola into a standard form parabola. So, before we even start, make your observation. What are we looking at? X is squared. So if x is squared, I'm aiming for this format, right, for my parabola. In order to get this squared binomial of x, do I have any other x terms? Darn it, I do. So I'm going to have to complete the square here. And again, I said this in the previous video, I'm saying it again. We only have to complete the square if there's another x term with the x squared term. Okay? And before you start thinking like, oh, woe is me, when we get to ellipses and hyperbolas, we're going to have to complete the square. Don't cry. Okay? So, when we want our x terms all on one side, we're going to move our y terms over to the other. So we have x squared minus 2x equals a positive 4y, because that's a negative 4y, minus 9. Okay? Now let's go to work. We should be comfortable with this by now. We take half of this number. What's half of negative 2? Negative 1. What's negative 1 squared? Positive 1. So I put a plus 1 here. Now, I added that. That wasn't up here. Show me where the plus 1 is in this problem. Right? It's not there. I added that. And I added it in an equation that I had set up. Right? This is an equation. What do equations have to have? Balance. So since I added 1 to the left side, I'm also going to add 1 on the right. Now again, in the past it was I had to undo it. I'm not undoing anything right now. What I'm doing is keeping the balance of this equation on both sides. Okay? Now from here, I'm just going to rewrite this all in the same ink tone. We get 4y. Now when I add 1 to this, I've got a minus 8. Right? We're going to add a different wrinkle to this problem. Now, on the left-hand side, the whole purpose of adding this 1 was so that I could write this as a squared binomial. What number goes here? Do you remember now? It's half of whatever I got when I divided this by 2. That's negative 1. So there's my squared binomial for x. Great. Now over here, here's where things get a little different for us. Right? In the previous problem, if you watched this video, all I was left with over here was negative 4x. So I just wrote this as negative 4x minus 0. Okay? So in other words, I needed, let me go back. I needed a binomial. I needed something. I know it's a 0, but I needed something in that binomial to tell me what I was subtracting from x. Okay? And only from x. Now take a look at this. This you're thinking is that, right? But it's not. And here's the subtlety to it, so please pay attention. In this binomial, there's no coefficient for y. There never has been. So I'm not supposed to have this number here. Okay? What I should do is factor it out. So what I need is, I want y in that binomial. I don't want a number in front of it. So I'm factoring the 4 away from that. And it just so happens, I can also factor 4 away from this. Right? We want y with no coefficient inside that binomial. So we end up in this scenario. Okay? So here's what we know. Once we're written in standard form, the vertex, whatever I'm subtracting from x, whatever I'm subtracting from y. The focus, that's p units away. So take this coefficient and say 4 is equal to 4p. Therefore, p has to equal 1 when we divide both sides by 4. So p has a value of 1. How does this parabola open? Because x is squared, we know it opens up or down. And because p is positive, we know it opens up. So, we have our little picture over here, 1, 2. And again, it's not perfect, this line's slanted. It doesn't matter, we just need a sketch. So our vertex is 1, 2. The p-value is positive. So I know this parabola has to open up. Since p has a value of 1, I'm moving 1 unit above the vertex to get the focus. That would be at 1, 3. And the directrix, you guessed it, 1 unit below the vertex. Sorry, I should get a little cleaner with that. That's going to be at 1, comma 1. So I'm moving 1 unit up from here to get to the focus. I'm using 1 unit down, losing 1 unit down from there to get down to the directrix. So here is all that important information after we completed the square.